All right, give me a second. All right, so we're officially starting our Cap Theorem presentation made by André Carvalho. André, you can share your screen, talk a little bit about you, and then you may start the presentation. We'll have
Okay,
a moment of questions by the end of the presentation, okay?
nice. So, guys, I want you to be here until the end of the presentation because I want to make a practical exercise with you. So, I want to be an interactive approach. So,
Nice.
it'd be amazing to hear all of your opinions. Can you see my screen?
Yes.
Nice. Just let me try to hide the Zoom pop-up. Okay, guys, so come on. I am André, and I'm here to talk to you about the Cap Theorem in system design interviews. So our purpose here is to understand what is Cap Theorem and its fundamentals and how it can help us in the system design interviews and understand all of the main concepts. So what is the Cap Theorem? It is proposed by Eric Brewer, and Cap Theorem states that distributed systems can only guarantee two under three properties, and they are consistency, availability, and partition tolerance. And it's important to highlight that it only makes sense when we are talking about distributed system, because we only have partition tolerance in distributed systems, because we have multiple nodes of our application, being an web application, for example, or a database. And first of all, what is consistency? So consistency just ensure that every read in our application is able to see the same data. So no matter what is the node of your application you are calling, you will receive the same answer in all of them. So whenever we write something in our application, it will be available for all the nodes at the same time for reading. It means basically nobody's going to read different data from your application. And of course, that's vital for systems that needs precision, like banking systems, and up-to-date data. On the other hand, we have availability, and that it ensures that every request receives a response, being error response or success response, no matter. And even if you have node failures, an available system will remain operational even if some parts of the networks are down. So if you have some momentaneously instability in your network, in one of your nodes, the rest of your application will be able to respond. So if you have three nodes and one of them is failing, you still have two of them available to respond to requests. And the system remains accessible despite the failures, and we can prioritize this when we can have tolerance for eventual consistency. And what is partition tolerance? Partition tolerance is the ability of a distributed system to continue to operate even when there are network failures. So for example, in consistency, we can have distributed systems, we can have microservices, and they are still work despite that, despite of partition failure, because you still can have multiple nodes, but with consistent data. So the system functions despite the message loss or network splits. We have also network resilience, and it's essential for the distributed architecture. When we have to prioritize C versus A, consistency versus availability. So that's the main trick when we are talking about Cap Theorem, and this is what will help you and will make the difference in your system design interview. So we have to choose consistency, especially when we have financial transactions, when we have booking or inventory control. So imagine you are accessing a movie theater booking application. So if you pay for a slot in the movie theater, nobody else can buy the same slot as you. So, and by the way, it's called overbooking, and it happens in ticket booking or even hotel booking, for example. That's a very common problem in the industry, by the way. And availability is when uptime is more important than consistency. And when we have the scenario, especially in social medias, so imagine your friend posted a video or a photo. What is the most important? Is to see the most recent posted photo or to have the system available? So you are still able to see the posts, but not the most recent. So in this case, of course, what we want is more availability. No matter if we don't see the most recent post, but we are still able to see some of the older posts. Content delivery networks, user profiles. So it's we are not required to see the most updated information. It's more important for us to be able to see the profiles. And to ensure all of that is really important to know the different types of database, because we have specialized databases for each of the acronyms. So we have databases specialized for consistency and also others for availability. And the most easy way to compare this is SQL databases versus NoSQL databases. So it's really important to you to understand all the aspects of ACID transactions. And we all know that ACID transactions are guaranteed by the SQL databases. And we have Postgres, MySQL, Spanner. Pay attention to this database. This is a Google Cloud database. Sometimes it can be useful. It's like a SQL database, but distributed. So you have multiple nodes of this database. So it works like a MongoDB, for example. You have multiple write and read replicas of the database, but it ensures you consistency. But in the other hand, you lose in the performance, because whenever you have a write operation, it only allows you to read the same data when the read operation is propagated to all the nodes of the database. So we want to prioritize strong consistency, and it's maybe unavailable during the partitions, even with this kind of database. We actually, there is a term for those databases. It's called NewSQL. Some examples of them is Spanner and CockroachDB. So despite the fact you have a distributed database, it's unavailable because if one of the nodes, you have one of the nodes failing, you will not be able to write or read data while you don't recover this node. So, and that's why you sacrifice availability, even with a multi-node database. And available databases are the traditional NoSQL databases, DynamoDB, Cassandra, React, MongoDB, Redis, and it's still able to serve data when you have partition failures. It's also important to understand why you are not able to have CA systems, consistent and available systems, because you only can ensure this if you have a single node database or a single node application. And it's the total opposite of distributed systems, because this, of course, in distributed systems, you have multiple nodes. And you don't have network, it's not applicable for distributed environments. Also, an important aspect is you are able to define consistency levels for NoSQL databases. For example, in MongoDB, you can prioritize consistency, but you have to you need to have in mind that if you choose consistency, if you choose to configure MongoDB to have more consistency than availability, you will lose in performance and also in availability. Some of real-world use cases are banking systems of because we want to avoid double spending, we want to avoid operations with negative balances. So can you imagine a withdrawal with a zero balance? So for example, you send multiple withdrawal requests, and for some reason, because of risk conditions, you allow to deduce the balance with you allow to deduce a zero balance operation. Amazon DynamoDB, it offers you eventual consistency in a very large scale database. You can have incredible high traffic operations using DynamoDB. Dropbox file sync, what we want to prioritize here is availability. And ticket booking, as I explained it before, what we want here is consistency. So some tips for your interview: focus, try to demonstrate understanding about the aspects of Cap Theorem. If possible, try to explain, try to ask what is most important, if it's consistency or availability. Be aligned with the requirements. You have to justify your decisions based on the requirements. So if it's not clear for you, you have to ask to the recruiter. I faced several interviews where they didn't explain everything in the initial requirements, and during the conversation, they expected from me to ask them. Do you understand that? So by their own, they didn't explain everything, and they were just expecting from me to ask them. That was like part of the interview. Consistency models show your knowledge about the strong and eventual and weak consistency, and if possible, explain the trade-offs between your decisions. Okay, so you have to assume that partition tolerance is given. It's a requirement for distributed systems. Match your priorities to the business needs. always connect your cap choices back to the specific requirements and failure scenarios. Pay attention on these failure scenarios. So start to design your application and with the recruiter. I can hear some noise from one of you. Okay, that's good now. So try to pay a lot of attention in these in failure scenarios. It happened to me several times. I designed an application and the recruiter asked me, okay, and what happens if something fail here? So be prepared to explain the failure scenarios, okay? And if he don't ask you, try to ask him. So if you notice that he didn't ask you anything about failures, he's expecting from you to have this question. Okay? And know your databases, be familiar with the types of databases, be familiar with consistent databases, with available databases, and practice your explanation. That's the end of the presentation. If you have some questions, please go ahead. Don't forget, I have one example, like a practical example here to work with you, but I want to hear first your questions. Guys?
Go ahead, guys. You can use the just start talking, or you can use the reaction to raise your hand if you want, like this.
I will stop sharing my screen. Vini, can you start your whiteboard?
Yeah, give me a second. Feel free.
Guys, feel free to ask me whatever the question you have, please.
Start raising your hands, guys, so we can make a line.
Okay, so if none of you have a question, I guess we can proceed to this practical example.
I actually do have one. I wanted to see if like systems can switch between CA, CP, and AP modes. Is it possible?
Interesting question. I guess you can implement an approach for that. And in banking applications, for example, something what we wish is redundancy. Redundancy, is that correct?
Redundancy, yes.
Redundancy. So one application I'm currently working on, I have a subscription hub for the credit cards of the customer. So despite you want a consistent approach for the transactions, it's not really necessary to have consistency to display all of the transactions, all of the subscription transactions of the client. So I have access to all the consistent transactions through a topic, and then I have like a redundant copy of those data in an available database. So first I ensure on the consistent data, and then I move this consistent data to another available database. So, and
Okay.
that's a very common approach.
Nice. I think I got it. Thank you.
Notice in this example, you have two different databases with the same data.
Okay. So you can switch between them.
Yes.
I see. Okay.
But to
Nice.
perform, the operations, we have the SQL database.
Perfect. Nice. Thank you. All right.
Then
Very
now,
nice. Anyone else? Any other questions?
I want to hear your voice.
Here is my voice.
Do you have questions? Do you want to share something?
When it comes to financial services, how would you say that I think maybe considering the use of NoSQL databases and SQL databases, how would you say would be the scenario? Are they using more and more NoSQL databases, or they still sticking with the SQL databases? What's the scenario that you can feel around?
I'm currently working for two clients, and one of them is a banking company, and most of the applications I'm working of them, I have access to several microservices, and they are all using MongoDB. But what we need to have in mind here is those are only non-critical applications. So, but I don't have access to the more critical applications, but I just imagine they use NoSQL database for those non-critical and SQL for critical applications.
I ask this because one of the reasons for you to use a NoSQL database is exactly the performance. Since they are non-structured, you can reach higher and higher throughput using NoSQL databases for some scenarios, of course. But and when it comes to the financial sector, I guess they are desperately in need for more performance from their application. So that's why I'm asking. I'm guessing that they are using more and more asynchronous solutions and NoSQL databases.
Yes, I think so as well. In my opinion, a common approach to use asynchronous operations is because you have more time to persist that asynchronous operation into a SQL database. So you can send 100 million requests, operation requests, but as you are processing then asynchronously, you can like put a rate limit for them. So then you can be sure you performed all of the operations, and just after that, you send a return to your client.
Yeah.
Arthur has a question.
Go ahead, Arthur.
Yes. Could you hear me? Okay. I have a design system interview in a few days, and I'm preparing for some questions, and I'm looking for a good architecture that is, for example, let me remember. So, a company has several customers in the world, and this company has multiple clusters in multi regions, right? Brazil, Japan, United States, Europe, and the database is located in the United States. And in United States has some private data like PII from USA residents, right? So the question is, we should ensure that sensitive data from the USA not be shared, and all the clusters above the countries like Brazil or China or Japan should be propagate this data. So there's a constraint that the updates should be propagated in less than 5 minutes. So I need to draw a system design that solve this problem. How can I design this system to bring this solution? Don't know if I'm clear, but it's a replication scenario. So you have multiple data centers across the world, and you need to propagate this data from USA to these another countries with the constraint of should be less than 5 minutes to propagate this data.
Ju-
How can I add, sorry,
just to
but
make sure I got your point. So you have an application running all around the world, right?
yeah,
Countries, and you have the same database for all of them, or you have different database for each country?
different databases on each country, but in USA has specific data that um should not
Shared.
be propagated for the another database.
Okay, so we call this approach sharing databases. So you have your database, you are sharing by country. That's the regular approach, by the way. But if I'm not mistaken, that's more like a data engineering problem. I'm not very used to those of data engineering. Am I wrong, guys?
Yeah, I have a suggestion in this case because then if you can suggest using AWS tools for that. For example, rep, rep, sorry, ih, rapaz, não vai sair não. Replicação de dados.
Data replication.
Data replication. For example, you can use data replication tools for that if you have options to using tools, because as André said, it's show more relation to database problems, infrastructure around database, and then software architecture. Because if you put the software, they'll develop something. Probably use develop a pipeline data, for example. You put to get the log or their event on your database and share this for others.
Yes.
Just my idea.
There is a tool, I'm not very used to that, but it's called data flow. Data flow allows you to construct data pipelines. But as I mentioned, I'm a backend developer. I'm not very used to data engineer tools. So if we have a data engineer here, please show up.
Okay, but it makes sense because we need to propagate the data, specific data, to all the database all across the world. So if we use a replication data tool like a data flow, we could replicate this data. I don't know if the constraint will be achieved because has a 5 minutes of limitation to be propagated. So it's a good system design that I want to understand, because it's a common it's a common question when we talk about, okay, financial system design. It's okay because we have a lot of financial guys here. But in this scenario, like replication, data replication, would be interesting to know about it.
Yes, sure. I guess I have to study about that because
Me too.
okay, I'm a backend developer and I know that's more common for data engineers, but definitely we all backend developers have to know knowledge about this situation.
Okay, I'm backend developer too, but it's a common question when we talk about uh, that data pipelines or don't know
Mhm.
Python tag stack. So these are common, but
I've
I
already
need
used
to study these too.
I've already used Camel for something like that because then I use in their I don't know this name. There's these tools that listening and chant in the database and put this change inside their Kafka, and the
Mhm.
camel consume that message, connect, select this data in that bank because this Kafka already used it for trigger and put this and listen in these topics in, over camel, and camel insert or share another structure or bank you have. Camel, it's easier to develop that and faster than, for example, you creating API or something. I don't know. I never use a flow, but here, yeah, Camel could be a good approach.
Yes.
If you are trying to solve this in developing backend layer, but in data layer, we have a lot of tools that Data Spark, I think.
Yes.
Nice. I asked for ChatGPT about this problem. He said that we could set up a multi-region database with asynchronous replication using DynamoDB global tables or Cassandra or CockroachDB that ensure the eventual consistency within 5 minutes. So
But you have the requirement of data from US to be isolated, so not sure.
yes, yes, this is another suggestion. You would store sensitive data in USA only, prevent it be replicated. So you should use encryption and common level access control. And this DynamoDB global tables has these features to avoid be public this data. So for the first problem, we could use encryption and table level access to control. And for the replication for all the countries, we could use a synchronous application using this DynamoDB technology.
Mm-hmm. Nice. It's amazing to see, guys. No matter how much knowledge we have, we always have something else to learn.
Yes.
It's
That is true.
complicated to be a developer. Okay, guys. Anyone else? Right. So we can proceed to this exercise. Guys, those are requirements for an e-commerce application, and I want to know your opinion about how would we design this. And here I put some specific keywords to help you to identify what is the most important in each requirement. So the first one is our product search. What we want is an efficient search and filtering of products in the catalog with a low latency. So how would you design this? Uh, what is the most important here, considering the Cap Theorem? I want to hear from you, please.
when we talk about low latency, we should ensure that is partition fault tolerant, right? So you need a system that at least has partition, right?
Yes, but don't forget, partition is already given for distributed system.
Already what? Sorry?
Is already given.
Already given.
Yes, so you have partition tolerance. If
It's
you are
expected,
working
right?
in a distributed system, if you have microservices.
In my opinion, for a product search, probably it's necessary to ensure the high availability of the data.
Nice. Anyone has a different opinion? Okay, so I just draw this box here, and as Jeter said, what we want here is high availability, and for high availability, what we use? MongoDB.
MongoDB, Elasticsearch.
Yes. Yes, you are right. So a very tricky thing here is low latency. Okay, we already have high availability, and MongoDB can also provide a certain level of low latency. But how can we improve this low latency?
Using cast approach.
Using what?
Cache, sorry, using cache approach.
Nice, you're right, my friend. So you see, guys, here we have kind of a redundancy approach, even using a cache database. But sometimes it's helpful to have redundant data in our application. So it seems good for now, but we have more requirements. We have a shopping cart functionality. So we want to add and update, remove items which are cart persistence per user. So I want to make this information persistent. We don't have any requirement, anything related to consistency or availability. So we just want to make it better for shopping cart. So analyzing a shopping cart, what would you say? Is it important to save it during a long time? What is the most important here? To have consistent updates in our shopping cart?
Consistency is important in this case, right?
Do you prefer consistency over availability here? Why?
Let me explain. When we need to persist some information, we need consistency because shopping cart, for example, you buy a product in Mercado Libre and you pay for this. But in another customer has interest in this product too. But in this case has one product in the inventory. So you need the consistency
Hey,
to ensure that
I got your point, Arthur. I got your point. Just to try to explain you, pay attention because shopping cart is not exactly the act of buying something. You are just picking the products and put them in the cart. You know, you are not definitively paying for them, you know?
Okay.
You
Okay.
just pick this product and maybe I will buy, maybe not. Do you agree?
Yes, yes. In this case, in this case, it's availability.
Anyone else has a different opinion?
Oh, sorry. Probably there is a space here to have some tolerance failing and some eventual inconsistency by using a shopping cart with not a very constant using a constants for a strong key. I think with it's I don't know how can I say it's there is a tolerance for some fail,
Yes.
like eventual data consistency.
Yes, eventual consistency is something we tolerate here, right?
Yeah, that's it.
Yes. In my opinion, for this situation, I will choose. Um, I would also choose MongoDB. As Jitter said, we can have eventual consistency here, and what we want is make our system available more than consistent. Consistent. Seems good to you guys.
Very nice, man. I liked the exercise
No,
to
we still
practice
have
the
more.
idea.
We still have more.
Yeah, I know, I know.
We still have more. Don't you worry. Just let me write here. Availability, cache. Just fix this word for me. Okay, now our next requirement. We want a checkout and payment processing. We want to secure checkout flow with integration to the two payment gateways.
This
So
is
what?
a critical application, so
Yes,
consistency is more important than high availability.
yes. Anyone else with a different opinion?
When we talk about Cap Theorem, why we don't sorry, I just have a doubt because why we don't show the partition in this name? Like the shopping cart should be availability and partition, or no partition. And checkout payment. Okay, it's a consistency, but should ensure também should ensure to uh, partition or no? Like
Again,
CP or AP?
you always have AP or CP, right?
Okay.
Partition is, as I mentioned, is already given. You have partition by default because you're
Ah,
working with microservices.
okay.
Did you get
Ah,
that?
yes.
Imagine partition like multiple nodes. So you have multiple nodes because you are running microservices, you are running distributed databases. So it's already given for you.
Nice, nice.
And
That's
even
true.
SQL database, imagine you have a Postgre database, right? You can have multiple nodes of your database because you can have only read replicas and only write replicas. So you have partition. But
Nice. By default, right?
yes, yes, it's by default. But
Okay.
you have consistency because when you write something, it's in the moment you write something, it will be replicated to all read replicas. and all of the everybody that is consuming the data will be able to see the same data at the same time
Okay, nice, man.
of the
Thank you.
replication. Good, good, good. So here we have AP, here we also have AP, here we have CP, we have consistency and partition failure. Checkout and payment, SQL database. Okay, seems good. And what about the inventory management? We have a real-time stock updates to prevent overselling. How would you solve that? Arthur, please feel free.
Yes, in this case it's CP, right?
I agree with you.
At least one I acertei.
No
You
worries,
got it
man, no
right.
worries. You are doing great. You brought valid points here to discuss. In the shopping cart, for example, you mentioned you mentioned that we have to display to the customer the right number in the inventory. And you are right in this point, but we just have to
Yes, yes.
have to take care about how can we display this information to our customer. There are different ways, and I want to discuss that in a few minutes. And Dieter, my friend, see you. Unfortunately, you can be with us.
See you, my friend. Have a great Friday.
Okay, so in the inventory, we want high consistency. And seems good. We also want a hot order history and tracking. We want to view the past orders and track the delivery status. What is your opinion about that?
View
Order, you
pattern.
can
Okay.
use the no problem. It's possible to use not the consistency. Its availability is more important because the in the past, not the present, I believe.
Yes, yes, seems good. Seems good. We can make a mix of approach here, but in my opinion, availability is more important here because you can process the orders in asynchronously. So whenever
Yeah.
you finish the process, you can just send a message for whoever is interested in this new status. Okay, guys. My next question is, how do you connect all of those services? Because we make all of them separately. We didn't connect anything. So I want to hear your thoughts on that. For example, how do we connect the product search with the inventory? What are the concerns here? Bye-bye,
Hmm.
Danak.
Using a
You could use
BFF
a event
approach.
broker, right?
Who say what?
Yeah, Arthur.
Okay, Arthur, feel free to
Yes, if you want to connect these 2 points, I don't remember. It's inventory and other
product
one,
search. I want to
product
display
search.
the right number of products, available products in the product search.
Okay, you could just uh, send an event data And inventory could consume this information using a synchronous mechanism.
For example, I added 100 MacBooks in our inventory. How do we update? How do we display this number for the customer?
Okay, we have this information, and we could publish this in a topic that product search will read. And the
Draw
product
it for
search,
me.
sorry?
Can you draw it for me?
Oh man, I'm in a phone right now. Sorry.
No worries. So I will try.
I don't know.
Let me try to draw here. Oh no, better. Lima, draw it for us, please.
Oh, it's harder to draw in cell phone.
Lima or anyone else, feel free to draw it for us. Anderson, it's a long time I don't see you, my friend.
Hey, hello.
Participate in the exercise, please.
Yeah, I'm trying, but I just popped out of an interview, so I'm trying to figure out what is happening here.
So basically, we are talking about Cap Theorem, when you have to prioritize consistency over availability, or availability over consistency. What are the types of database you use in each scenario, and how do you how do you detect when you have to use each one based in the requirements?
I'm searching better right now about the Cap Theorem.
Okay, guys, so I'm going to draw it. I didn't see anyone doing that. So product topic here, we just, when we have an update here, we send a message to this product topic. And then this message will be propagated for the product search. There is a term for this pattern. We say source of truth.
Source of truth is when I create the product in product services, I replicated the services in another. That's awesome.
Yes, you're right. Here is our source of truth, and we are replicating this data to our non-critical systems, the shopping cart and the product search.
I do this, but I don't know about this exactly name. Source truth.
Source of truth.
Using this like a query segregation in the CQRS query segregation between search and select and search.
Yeah, that's useful. So okay, we are propagating the number, the amount of products. What else, guys? What else you see is necessary here? For example, when you finish a checkout and you want to deduce from the inventory, how would you make that? Is it a synchronous operation, a synchronous operation? What's your opinion?
That's synchronous because I need the consistency in inventory for show this information on another users.
Mm-hmm.
I can finish. I have I don't know if he can use here for Saga Partner. You can process for another services, but I will have services main control the process. I don't know that's will use it for this example here.
Yeah,
I
follow the
agree.
same approach because in the payment you have for example, credit card confirmation. You can segregate this in stage. For example, waiting, payment confirmation, and payment confirmed, and tracking on delivery. For example, in payment and inventory. Because if I take something of inventory and I don't have the payment confirmation, it's create an inconsistency.
Yes, yes.
Yes, you could lock, right? This information until the payment goes be confirmed. You could lock using Redis or a table
That's
just for this lock.
That's good opportunity because it's possibility when I buy the product and publish the or card the services in this between this process I can another users buy the last product. That's important. That's a good opportunity. Put the Redis to lock the process. After finishing the process, I unlock this product.
Yeah, seems a nice approach. I didn't think about any of that, guys. I would just suggest you to send a request from here to here, but you're right. There are multiple ways to do it and make it safe. I like it. I like it.
We could build a e-commerce.
We are step
Yeah.
about that. Guys, I guess we are done here. We can discuss a lot of more things here, but we did a very great job. We shared a lot of knowledge here. I'm very happy about that, to share this knowledge with you and also learning with you. So thank you a lot.
Very nice. Very nice, everyone. Awesome. André, thank you very much. It was a very fruitful presentation. My friends, we're gonna wrap here. Let's take a picture and yeah, let's enjoy our Friday. 3, 2, 1. All right, everyone, thank you very much. Have a great Friday and an awesome weekend. See you all on Monday. Bye
See
bye.
you
Stay safe.
guys. Bye bye.
Bye bye, guys. I will
Bye
send you the
bye.
presentation, by the way.
Yeah, send it on our group.